Hi everyone, welcome back to my YouTube channel. As promised, this is the second part of the video, parallel and perpendicular lines, with most of its emphasis on perpendicular lines. You may watch the previous video, that is the part 1 video on the channel. It's already available. In this video, we will learn about the relation between gradients of perpendicular lines. Next, we will see how to determine whether the two lines are perpendicular to each other or not. Next, we will check out a practice question where we will find the equation of a line perpendicular to another line. So let's get started. Let's understand the relationship between the gradients of perpendicular lines. We know that perpendicular lines intersect each other at an angle of 90 degrees. Right? What is the relation between their gradients? The product of gradients of perpendicular lines is equal to -1. Let's understand what that means. For example, the gradient of this line is equal to m1 and the gradient of the line perpendicular to it is m2. Then the product of these two gradients, that is m1 multiplied by m2, is equal to -1. Now, it's time for some practice. Check whether the lines y is equal to 5x minus 1 and 5y plus x is equal to 15 are perpendicular to each other. In order to understand whether the two lines are perpendicular or not, we will first find the gradients of both the lines. How do we find the gradient? For that, we need to know the slope-intercept form of the line, which is y is equal to mx plus c. So in this case, y is equal to 5x minus 1. What is the coefficient of x? The coefficient of x is 5. And hence, the gradient of this line is equal to 5. Let's say the gradient is m1 and that is equal to 5. Let's take a look at the second line, which is 5y plus x is equal to 15. Now, in order to find the gradient, I will first get the line in this form. So let's move all the x terms on the right side. So 5y is equal to minus x plus 15. I need to get the coefficient of y as 1. So I'll divide by 5. So 5y by 5 is equal to minus x upon 5 plus 15 upon 5. Hence, y is equal to minus x upon 5 plus 3. Now, what is the gradient of this line? The gradient of this line, let that be m2, is the coefficient of x, which is minus 1 upon 5, right? Now, let's check the product of these two gradients, that is the product of m1 and m2. So, m1 multiplied by m2 is equal to 5 multiplied by 1 upon 5. So, 5 into minus 1 by 5 is equal to minus 1. You can observe that the product of gradients of both the lines is equal to -1, right? And hence we can say that both the lines are perpendicular to each other. Cool? Let's take a look at the next example. Find the equation of a line perpendicular to y is equal to 2x plus 4 and passing through 4, 1. First, we'll find the gradient of the given line. By comparing it with slope-intercept form, the coefficient of x, that is 2, is the gradient of this line. We know that for perpendicular lines, the product of slopes or the product of gradient is -1. So let this be the gradient m1 and for the line perpendicular to it, the gradient let it be m2. the product of these two gradients is equal to minus 1. Now m1 is 2, so 2 times m2 is equal to minus 1, and hence m2 is equal to minus 1 upon 2. We have found the gradient of the line perpendicular to given line. So let's write the equation in this form, that is y is equal to mx plus c, where m is minus half into x plus c. Now c is unknown, right? But we know that the perpendicular line passes through the point 4, 1, which means we can substitute the coordinates of this point in this line and find the value of c. So let's substitute it. Now x is 4 and y is 1. So 1 is equal to minus half into 4 plus c. Now 2 times 1 and 2 times 2. So 1 is equal to minus 2 plus c. 1 plus 2 is equal to c. Hence the value of c is equal to 3. We know the gradient as well as the value of c, and hence the equation of line that is perpendicular to the given line is y is equal to minus 1 by 2x plus 3. Isn't that simple? So kids, that's it for today, and please like, share and subscribe to my channel for regular updates about educational videos. Stay tuned.